Okay, so now we're going to be doing chapter 13 of my book, Overcoming ACT Math by Sophia Garcia. It's available on Amazon if you're interested. What we're going to do is review the formulas first, and then we're going to go into the questions. So here are just some of the formulas that you should remember. So like the volume formulas for all the different types of stuff. So R just means radius, H is height, L and W are length times width. Now for a cube, you can think also of like side squared, people sometimes say, or side cubed, I mean, for volume of a cube, sorry. But it's the same thing as length times width times height. It's just essentially that they're all the same. So you get S cubed, like the side length cubed. So that's why I kind of like lump them together. And then over here we have the surface area of a cylinder. That's a special formula. For everything else, you basically, it's in the name, surface area. You find the area of each of the surfaces, like top, what's the area of the top face, the bottom, the sides, and then add them all up. That's the area of all the surfaces, surface area. And then area of a trapezoid is this right here, where H is the height, and B1 is the first base, and B2 is the second base. And area of a parallelogram is just base times height. Now, if you have a polygon, the sum of the interior angles is going to be 180 times n minus 2, where n is the number of sides. And the sum of the exterior angles is going to be 360. So let's get started. So it says for number 1, for a regular dodecagon, how large in degrees is the interior angle? So remember, the interior angle formula right here, the sum of all of them is going to be equal to that. So I want to find just one interior angle, not necessarily the sum. So the sum would be represented by 180 times the number of sides, 12, minus 2. That's the sum of all the angles. Now, if I divide by the number of sides, 12, I can get how many each angle is, because then there's going to be 12 angles within this, a dodecagon. So if I divide by 12, I find out what each interior angle is equal to. So then remember, this is ACT, so you have a calculator available to you. So that's going to be 150, so it would be D. This is for ACT math for people asking. So let's go to number 2. It says, what is the length of a rectangular solid with a volume of 440, width of 8, and a height of 5? So remember, the formula for volume of a rectangular solid is going to be volume is equal to the length times the width times the height. So they tell you the volume, so I can plug that in for V, volume, 440. They tell us the width and the height, so I can plug that in for W and H. And then I'm just left with L, the length. So then I'm going to get 440 is equal to, this is just going to be 8 times 5 is 40, so 40L. So then you divide each side by 40 to get L by itself, and you'll have what the length is equal to. So when you divide by 40, you get 11, so it would be H. Would you recommend ACT or SAT for people that are slow? It really depends on the person. Like I would just take a practice exam of both and then see like which one you do better on. Typically, people tend to complain more about the pacing of the ACT. So it really just depends on you though, because it can go either way. So let's go to number 3. Suppose the height of a parallelogram is doubled and its base is tripled. Which of the following would be the ratio of the area of the new parallelogram to the area of the old parallelogram? Okay, so area of a parallelogram is going to be equal to base times height. So if, let's use like the term OG for like our initial parallelogram before we do anything to manipulate it. And we'll say that that's the original base and original height. And then we'll say for the new one, the area of the new parallelogram, it's still going to be base times height, but it's a different base and a different height. So this base is going to be tripled. So it's going to be 3 times the original base for the new base. And then for our new height, it says that the height is going to be doubled. So it's going to be 2 times the height. So then this should be equal to 6 times base times height. So it's asking us which of the following would be the ratio of the area of the new one to the area of the old. Remember, the area of the old was this one, BH. The area of the new is 6BH. So it would be 6 to, is it old to, it's new to old. So it would be 6 to 1. So 6. So then let me see, there were a couple questions. What grade math is this? This doesn't pertain to any one particular grade level. This is the ACT exam, so it's across multiple grade levels. Can you use the ACT prep book for the SAT if you already bought it? Yeah, a lot of this stuff carries over. If anything, the ACT one is going to cover more topics than the SAT. So yeah, you can definitely use it for that. And you can also, like, remember, all the videos are online, so you can also watch the SAT version as well. But it's going to cover a lot of the same skills. It's just maybe worded a bit differently. And it covers extra skills, if anything, the ACT book versus the SAT. So let's keep going. So let's go to number 4. For a regular hexagon, how large in degrees is the exterior angle? Okay, so remember, the sum of all the exterior angles is 360. Now, if we have a hexagon, that's going to be the 6-sided polygon. So if all of the angles are 360, like if we add them all up, it's 360, and we divide by how many sides there are, which is also how many angles there are, which is 6, then we should get that this equals 60 for each interior angle. So it would be H. So let's go to number 5. For the figure shown below, all side lengths are given in centimeters and all angles are right angles. What is the area of the figure in square centimeters? Okay, so this is one of the ones where you have to like cut it into little pieces so that you have like a bunch of rectangles instead of working with this big weird object. So what we're going to do is let's cut it like this. Let's see, like that. And then that way I'll have 1 times 3, and I could get the area of this little guy right here. And the area of this rectangle is going to be just length times width, so 3, because it's 1 times 3. And then let's cut it like right here. So then here you're going to have, remember, this whole side is 5. So if we're talking about just this guy right here, it's going to be 4 because this is 1. And plus whatever is here has to add up to the whole side length of 5. So this has to be 4. So that's going to be 4. And then we can also say that 2 plus 3 is 5. So that means that this right here is going to be 5. So we're going to say 5 times 4 gives us the area of this rectangle right here. So that's going to be 20. And then now if we know this is 5, we know that this is 5 because they have to add up to 10, because that whole side length adds up to 10. So now to find this rectangle right here, the area of this rectangle, it would be 12 times 5, which is just going to be 60. So I have the area of all the little pieces. If I add them all together, I get the area of the entire shape. So it would be 60 plus 20 plus 3, which is going to be 83. Okay, let me see if I missed any questions. Let's see. But what happened to the 10? I don't know what you're saying. The part always confused me, but when you're cutting it, your shape, does it matter where you cut? So it doesn't necessarily matter where you cut if you have enough information. So like you can cut it different ways as long as you're able to like figure out what the side lengths are. If that makes sense. You can cut it a different way if you're able to figure out what the length and width is for each of the rectangles in the way that you cut it. How is that 4? This is 4 because the whole side length is 5, and it said that this was 1, so that means this has to be 4 for the whole thing to add up to 5. Okay, so let's go to the next page. So now we're going to do number 6. So it says, for the parallelogram shown, what is the value of x? So these are just, I should have also put that this was in degrees. So 36 plus x, these are in degrees, so it's going to add up to, since it's a parallelogram, like the side, or not the sides, the angles that are next to each other are supplementary, meaning that they add up to 180. So that means that this has to add up to 180 degrees. So all we have to do is subtract 36 from each side to get x by itself. And when you subtract 36, that would be 144. So it would be F. Okay, so then when is the SAT prep? I'm doing ACT up until the 30th only because I have to get all the videos recorded by then for the ACT book. But after that, I'll be mixing it up with SAT and ACT. Okay, but a lot of this applies to both. If a rectangle has a length that is 7 more than double its width, then which of the following represents the perimeter of the rectangle? So let's draw this out. Okay, so it said that the length is 7 more than double its width. So let's label this width W, and we'll say that the length is double the width plus 7. So this would be like the picture. So then it says which of these would represent the perimeter. Remember, the perimeter is adding up all the side lengths, or you can memorize that thing. I mean, it also makes sense logically where it's 2 times the length plus 2 times the width. That works too. So that's what I'm going to do. 2 times the length of the rectangle right there, 2 times 2W plus 7. Plus 2 times the width gives you the perimeter of the entire thing. So then we're just going to distribute this right over here. So 2 times 2W is 4W. 2 times 7 is going to be 14. And then I'm going to add on 2W. So now I just need to combine my like terms here. And that's going to be 6W plus 14. So that would be E. Okay. So let's go to the next one right here. It says, how tall is a pyramid when the area of the base of the pyramid is 60 square inches and the volume of the pyramid is 180 cubic inches? Okay, so this would be volume of a pyramid. So we could say it's 1/3, and then we can say 1/3 length times width times height. But if you think about it, the length and the width is the same as the area of the base. So we could say just the area of the base times the height. And then we could say that 60 is the area of the base, which they already gave us. And then times the height, which is what we're solving for because we want to know how tall it is, times 1/3 is equal to, they gave us the volume is 180. So then now all I have to do is solve for h. So 1/3 of 60 is going to be 20. So then I have 20h is equal to 180. Then I'm just going to divide by 20 to get h by itself. And when I do that, I'm going to get that h is equal to 9, which would be g. So let's go to this one. If a cylinder's volume is 36 pi and its radius is 4, then what is the height of the cylinder? Okay, so volume of a cylinder is going to be equal to pi r squared times h, where r is the radius and h is the height. So we know what the volume is, 36 pi, so we're going to replace v, volume, with that. And then we're going to say, okay, we know what the radius is, it's 4. So we're going to say pi times 4 squared. And then we don't know what the height is, we're solving for that. So I'm going to cross out the pi's, and because I can divide by pi on each side, and then it cancels out to 1. So then I would have that this is 36 is equal to 4 squared is 16 times h. So now I just have to divide each side by 16. So then when I put in my calculator, or what I put in my calculator is going to be this, and then whatever that equals is going to be the height. So that would be 2.25 b. And then let's go to the next one. And, oh yeah, you could do that mentally too, like obviously, but most people are going to do it in their calculator. Like you could say that this approximately goes in 2 times because 16 times 2 is 32. And it doesn't go in enough to go 3 times. So then, yes, you can use the calculator the whole time on the ACT. Number 10, suppose a rectangle has an area of 120 units and a width of 10 units. What is the length of the diagonal? So let's draw this out. Okay, so it said that the area is 120 and the width is 10. So remember, length times width equals area. So that means that the length times the width, which they already gave us, so the length times 10 equals 120. That means that the length must be equal to 12 for that to work. So we also got length from that. So if we draw it out, it looks like this. And we want to know what the length of the diagonal is right here. So we'll call this D diagonal. And remember, this is a right angle right over here. So if we have the diagonal right over there, this is forming a right triangle. And how do we find a missing side in a right triangle? We use Pythagorean theorem. a squared plus b squared equals c squared, or in this case, it's d squared. So 10 squared plus 12 squared is going to equal the hypotenuse squared, d squared. So that's going to be 100 plus 144, and then, so that's going to be 244, and that equals d squared. So now, I'm not interested in d squared, I want just d, the length of the diagonal, so I have to square root each side to get that. And, oh wait, actually we don't have to find an exact value, we're just simplifying it, but you are square rooting each side still. So this would be the square root of 244 is equal to d. So then I think to myself, okay, what equals 244 when I multiply it together? So I could say that 4 times 61 gives me 244. And then I could say, oh, 4 is one of my perfect square things that I memorized. The square root of 4 is 2. So I can take out a 2 for this 4, and I could say I'm just left with the square root of 61, 2 root 61. So it would be h. So let's go to number 11 now. It says a rectangle has a length of 84.5 inches and a width of 2 inches. If this rectangle has the same area as a particular square, then what is the length of a side of that square in inches? Okay, so the rectangle has this length and this width, but the same area as the square. So let's find the area of this rectangle. The area of a rectangle is length times width, so it would be 84.5 times 2. So if I do 84.5 times 2, that's going to be 169. So the area of this rectangle is 169, and that also happens to be the same area as the square that they're talking about. Now, to find the area of a square, it would just be side squared is equal to that area. That's the formula that we would use, and we already know the area. So what number squared gives me 169? Well, that would be 13. So S has to equal 13. So that's length of a side of this particular square. So let's go to number 12. If a cube has a surface area of 216 square units, then how long is the edge of a cube? Okay, so surface area of a cube, you can think about it as like logically as it has 6 faces, like 6 sides of a cube, like think of a dice. There's 6 sides to it. And surface area is the area of all the sides added up. So it would be 6 times s squared, because s squared is the area of each of those square surfaces. Or you can just memorize that the formula for surface area of a cube is 6s squared. So 6s squared is going to be equal to 216. And we want to know how long is the edge of a cube, which is represented by s. So let's divide each side by 6. And then we're going to square root each side after that. So s squared is equal to, if I divide by 6 on each side, I think that's 36. 36 times 6, yeah, that works. So that's 36, and then s squared would have to be 6 then for that to work. So it would be g. So let's go to number 13. It says a cube has a side length of 4 units. What is the length of the diagonal of the cube? Okay, so excuse my drawing skills here, but we're picturing a cube. And, okay, I'm trying my best. Okay, so like we're picturing, I think that's okay-ish. That's bad. Okay, just picture a cube as best as you can. So we're going to picture a cube where the diagonal's going like this from one edge to the other. So it's like the front edge on the left to like the top edge on the right. And then I'm going to say that this right here, through the base, there's going to be a diagonal going through there. And then we're going to say we have a right angle right here. So remember, it says that they have a side length of 4. So this is 4. So now I'm going to basically redraw the triangle part outside so it's less messy. So this is going to be 4, and then we basically need to know this guy right here. This diagonal is what we're solving for, and I'm going to just call that D for diagonal. And then let's see, if we are doing it like that, then we're cutting this into a 45, 45, 90. Wait, is that a 45, 45, 90? Hold on. Let me think. Hold on. Cube. I hate that I can't draw this. Okay, hold on. Is that a 45, 45, 90? Yes, it is. Wait, yes, it is. It's a 45, 45, 90 because it would cut it in half. Sorry, I can't, like, with this picture, I'm visualizing it wrong. 45, 45, 90. So then let's see, if that's a 45, 45, 90, then this would also have to be 4 on the bottom. So this would be 4, 4, and then this is a right angle also. So then you could figure out what this guy is from that right triangle as well. This is so annoying that I can't draw it. Okay, so basically like the base has, pretend that this is the base. I'm going to draw the base separately because I think it's easier to see it that way. So this is just the base, like the square on the bottom. So each of the side lengths is going to be 4. So you can find out what this little dotted diagonal is here, which I'm representing with this triangle over here. You can find out what that hypotenuse is by doing Pythagorean theorem and solving for that side. And then you could say that this, and this is not going to be a 45, 45, 90. I thought I could assume that, but I don't think you can assume that. So we'll do it this way. We're going to do 4 squared plus 4 squared is going to be equal to c squared, which we'll call this c right there so that we don't get it confused with d up here. And then we're going to say 16 plus 16 is equal to c squared. And then that's going to be 32 is equal to c squared. And then we're going to say that the square root of 32 is going to be equal to c. So this is, the c is like the diagonal across the base right here of a cube. So like if you're thinking of the bottom of a dice, it's the diagonal right there. So that's what c is representing there. Now, if we think about like the diagonal of a cube, it's like the bottom left of a dice to the top back right, kind of. I wish I could draw this. I wish I was a better drawer. I'm going to try to draw it again for people that are confused. I'm really sorry. I'm just really bad at drawing. And it's like tripping me up. So hold on. We go like this, kind of like from the bottom left of the front to the top right in the back is what that diagonal is that I'm discussing. And then like on the bottom with the base, because like there's a square on the bottom, square base on the bottom. This guy is the C that I was describing right here. That's the C. And then so this would have to be, and every side length is 4. So what we did was we calculated the Pythagorean theorem here with 4 squared plus 4 squared to get C equals C squared to find out what C is. So now that we know what C is and we know that this is 4, and C is equal to root 32, we can now solve for what the diagonal is right here, because that's a right triangle. So we can say that we have 4 squared plus root 32 squared is equal to D squared. So that's going to be 16 plus 32 is equal to D squared. And then that's going to be 48 is equal to D squared. And then if we square root each side, we're going to have square root of 48 is equal to D. So then you could think to yourself, okay, how do I simplify the square root of 48? So that would be 16 times 3, yeah. So then 16 is a perfect square, so we could take that out as like the square root of 16 is just 4, and then leave a 3 in there. So then it would equal, for that D, the diagonal of the cube would equal 4 root 3. So then that would be E. One day I'm going to like print out something, like maybe I can like print out something that looks better than my drawing of a cube, and I'll try to re-record that portion. I'm sorry for my terrible drawing skills. Okay, so then we're going to go to number 14. A company sells shipping containers to clients who are building tiny homes. Each shipping container has the following. Oh wait, hold on. Did I say, wait, it's 4 root 2, someone said. No, it's not. It's 4 root 3 because 16 times 2 doesn't equal 48. No. Because it would be 4 squared plus 4 squared is equal to 30, or the square root of 32 squared. So this is square root 32. That's going to be 4. So then it's the 2 sides squared. 4 squared plus root 32 squared is equal to D squared, the diagonal. 32 squared is just going to be 32. So it's 32 plus 16 equals D squared. And then we're going to say that that's equal to 48 is equal to D squared. So then you just solve for and simplify the square root. It is E. Okay, let's keep going. Oh wait, I'm not on that one. I'm on this one. Let's go to a company sells shipping containers to clients who are building tiny homes. Each shipping container has the following dimensions: X feet by Y feet, by X feet. Oh, I think I see where someone was saying that where they messed up. Oh, I see what the confusion is. they're thinking about the diagonal of the base. That's what you're thinking of. You're finding the wrong diagonal. It's the diagonal of the cube, which is this guy. Okay, so let's see. Let's go to number 14. A company sells shipping containers to clients who are building tiny homes. Each shipping container has the following dimensions: X feet by Y feet by Z feet. A customer wants to special order a custom-made shipping container that will be triple the volume of the typical shipping container that the company sells. Which of the following could be the volume of the custom-made shipping container in cubic feet? Okay, so let's talk about like an original one. Original volume of the shipping container is just going to be the X times the Y times the Z, because those are the dimensions. And then the new volume, like the situation for the new volume, meaning like new is the situation we manipulate, where we're changing it to be, it says that we're getting triple the volume of the original one. So we want to get triple, meaning times 3, the volume of the original container. So we want 3 times whatever volume of the original container is. Now, remember, volume of the original container is equal to X, Y, Z. So we can replace volume of the original container with X times Y times Z. So we could say that this is equal to, the volume of the new is equal to 3 times X, Y, Z. Or we just say 3X, Y, Z. So that would be F. Okay, so then let's go to the next one. If a cylinder has a diameter of 20 centimeters and a height of 30 centimeters, then what is the volume in cubic centimeters of the volume? Sorry, I'm getting distracted by the comments. Is there something happening? Hold on. Just want to make sure no one's like, what is happening? Okay, I can't tell what's happening. Okay, whatever. If I see anything, I'm going to stop it. So just stop and behave, children. Okay, or adults. If a cylinder has a diameter of 20 centimeters and a height of 30 centimeters, then what is the volume in cubic centimeters of the cylinder? Okay, so we want volume of a cylinder. So volume of a cylinder is equal to pi r squared times h. So r is the radius and h is the height in this situation. So we could say that the volume is equal to pi times, remember they said diameter is 20 centimeters. We don't want diameter, we want r, the radius. Radius is equal to half the diameter, so that means that the radius is going to be 10. So it's going to be 10 squared times the height, which is 30. So then what we're going to do now is just multiply this all out and everything, and we just get that this is 100 times 30, so then that's going to be 3,000 and then times pi. So this is equal to 3,000 pi, which would be C. Okay, so then let's go to number 16. For the trapezoid shown below, the area is 152 units. What is the height of the trapezoid? So remember the formula for area of a trapezoid is going to be equal to half times the height times base 1 plus base 2. So then we know what base 1 and base 2 is. It's 12 and 26, so we can plug that in here. We know what the area is, so we can plug 152 in for A and then just solve for H. So that's what we're going to do. We're going to say 152 is equal to half of the height times base 1, 12, plus base 2, 26. So then we're going to say 152 is equal to half of the height times 38. And then we're going to say, okay, well, what is half of 38? Well, that's 19. So 152 is equal to 19h. And then we are going to divide by 19 on each side to get the height, because that's what we're solving for. So if I divide by 19 on each side, that's going to be 8. So h is equal to 8. So that would be this one right here. Hold on, because I have to check my notes, because I know there was something on this page that I wanted, and I think it's this problem that I wanted to mention, but I forgot what it was. Let me see. There's an extra way of doing, oh yeah, hold on. I remember what it is now. So if I wanted to mention for people watching this later on YouTube, there's a different way to do this that you that you can do this basically without remembering the formula if you forget it. What you can do is you could cut it into like triangles. For a lot of these trapezoid problems, you can cut them into triangles and rectangles. You can do kind of like the thing that we did earlier with this, where you have a complex shape where you can cut it up. That's another way around memorizing the trapezoid formula for a lot of these types of problems. So I just wanted to mention that. So then let's go to number 17. So it says for number 17, a student draws a square on a piece of paper. If the student decides to increase both the length and width of the square by 10%, then the area of the square will increase by what percent? Okay, so let's talk about our original square. Oh my God, that's a terrible square. Our original square. So this is going to be our OG original square. And it has some length and some width. So the area of that is going to equal length times width. That's our original area. Now we have this new situation with a new square where we want to increase the length and the width by 10. So by 10%. If we're increasing by 10%, that means we're taking 110% of L and W. Because if you already have all of L, you have 100% of it. If you increase by 10%, you have 110%. So to find 110% of L, we would have to multiply by that as a decimal, so it would be 1.1 times L. And then the same thing for W, because that also increases by 10%. So it would be 1.1 times W, right over here. You could have also like said side and side, it doesn't matter. I just always think length times width for some reason. But you can't because it's a square. So then what we're going to do to the area is we're going to say, okay, well, now for area, I'm going to say that I'm multiplying length times width for this new area. So it's going to be 1.1 times 1.1 times length times 1.1 times the width. Again, you can think about this as sides if you want, if you like using S instead. No big deal. It works out either way. So then what we're going to do here is we're going to multiply this all out, and this is going to give us the new area. So that means that the new area is going to be equal to, well, 1.1 times 1.1 is going to be 1.21. And then just times LW. Now remember, LW was the original area, the OG area. And it's asking us the area of this new square will increase by what percent. So we want to know by what percent did the original area increase. So we can replace the LW with the area of the original square. So we could say it's 1.21 times the area of the original square. So 1.21 times that means that it had to have increased by 21%, because if we turn 1.21 into a percent by moving it over by 2 place values, that would be 121% of the original area that we're talking about. All of the original area is 100%. If you add 21%, then you get to 121%. So that means that they must have increased by 21%. C. So let's go to the next one, which is number 18. And it says, Chad is throwing a party at his fraternity. He estimates that each guest will drink 4 cups of his signature lemonade. At this party, each cup has a radius of 3 inches and a height of 12 inches. Suppose he anticipates 60 guests are coming to this party. The minimum capacity of a giant lemonade pitcher in cubic inches must be, assume the cups are cylindrical in shape. Okay, so let's calculate the volume in each cup, right? So the volume in one of the cups, and remember, we're supposed to assume that the cups are cylindrical in shape, so like a cylinder. So the volume of a cylinder is going to be equal to pi r squared. So pi times the radius of the cup, which is 3 inches, squared, times the height, which is 12. So that's the volume of one of the cups, and that's going to be 9 times 12 times pi, which is going to be 108 pi. Okay, 108 pi. Sorry, 108 pi is the volume of one of the cups. So now remember, they said that each of the guests is going to drink 4 cups. So each of the guests is going to drink 4 cups. There's going to be 60 guests. So it's going to be 4 times 60, because there has to be 4 cups for each of the 60 guests, and each of those cups is 108 pi volume. in volume, or cubic inches in volume, I guess is how you would say that. So then we're just going to multiply this all out. So then that's going to be, let me see, 25,920 pi. 25,920 pi. So then that's going to be B right over here. So let's go to number 19. It says if a cube has an edge length of 3 inches, then how many cubes would it take to fill a rectangular solid that has a volume of 216 cubic inches? Okay, so we have the total volume, 216 cubic inches, is our total volume. Now we can divide it by the volume for one of the cubes. Now, volume of the cube is equal to the side cubed, like the edge length or the side length of each of the faces cubed. So we know that that's 3, so it's 3 cubed is what we're dividing by. The total volume divided by the volume of one cube would tell us how many cubes fit into this rectangular solid. So then we just have to do 216 divided by 27. So then 216 divided by 27, that's going to be 8. So that would be F. Okay, so let's go to number 20. Hold on, let me just fix that really quick. Okay, number 20. The sum of the interior angles of a regular polygon is 1,260 degrees. How many sides does this polygon have? Okay, so let's see. The formula for the sum of the interior angles is just going to be like the sum of the interior angles, 1,260 in this case, is equal to 180 times n minus 2, where n is the number of sides that the polygon has. So all we have to do is just distribute and then solve for what n is. So let's distribute by multiplying 180 times each of these terms in parentheses. And then we could say that it's equal to 180n minus 360. So then we're going to add 360 to each side. So add 360, it's going to cancel out here. Add 360 over here. And then that's going to be 1,620. And then we're going to say that that's equal to 180n. So now we're going to divide each side by 180. And when we do that, we should get... that would be 9. So it would be 9 sides, B. So then let's go to number 21, and then let's see, if a roll of gift wrapping paper is 4 yards wide and 24 yards long, then how many rolls will be needed to wrap a present in the shape of a cube whose edge is 10 yards? Assume no gift wrapping paper overlaps. Okay. So let's see, we have that the gift wrapping paper, okay, so we could figure out the area of a roll, the surface area for the gift wrapping paper from this information right here. It would just be the 4 times the 25, so that would just be 100. And then, so the roll of one roll of gift wrapping paper is going to be 100 yards cubed, or 100 cubic yards. And then we could say that we have, it's a present with the shape of a cube, which is, okay. So then the cube, the surface area of a cube is going to be 6s squared. So that's going to be 6 times 10 squared for the surface area of a cube. Because think about it, like the surface area is how much area covers each of the surfaces. So you need to know that to know how much wrapping paper there's going to be that's needed. So it would be 6 times 100, so that's just going to be 600. So this is how much they need. And then this is how much is in one roll. So if we do the 600 divided by 100, we can get the number of rolls that are needed. So it would be 600 divided by 100. So then that would be that there's 6 rolls needed. G. How did I get 6? Because I said, okay, I need to find out the surface area of the cube, the present that's a cube, so that I know how much I need to cover all the surfaces. So surface area of a cube is 6 times the side or the edge length squared. So 6 times 10 squared gives you 600. So that's the total surface area. of the cube present. Now, the area of the surface area of the gift wrapping paper is going to be given by 4 times 25. So that's going to be 100 cubic yards. So if I have the surface area in one roll, I can then divide by that. I could say the total surface area that I need to cover this whole entire present divided by the surface area of one roll of gift wrapping paper is going to tell me how many rolls I need. So then that's how I got 6. Yards squared, sorry. I meant yards squared. I don't know why I put cubed. So then let's keep going. If a cylinder has a height of 2 centimeters and a radius of 2, thank you for the little gift. If a cylinder has a height of 2 centimeters, even if you use the 3, like, it doesn't matter what you label the units as right now, yeah, because there's no, like, unit labeling right there. I was just going too fast and not paying attention to, like, that we were talking about area, so obviously it's squared. Like, whenever you're talking about area, the units are squared, surface area or regular area, and then whenever you're talking about volume, it's cubed. I just did too many volume problems in a row and was thinking in volume units. Someone said I passed I think you're saying that you passed your SAT. Are you proud? Yes, I'm very proud of you. Are you Turkish? I swear I could hear it. Yes, I am Turkish. Well, half Turkish. So then let's go to, but I don't speak any of it. 22. If a cylinder has a height of 2 centimeters and a radius of 2 centimeters, then what is the surface area of the cylinder in square centimeters? Okay. So, if we want surface area of a cylinder, the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h, where r is the radius and h is the height. So they've given us what h and r is. They're both 2. So we could just plug that in for h and r to find the surface area. So surface area is going to be equal to 2 pi, oops, that's supposed to be a pi, times 2 squared, because r is 2, the radius is 2, plus 2 pi times 2 times 2. All I'm doing is plugging in 2 for r and h and finding the surface area from that. So then this would be 4 times 2 is 8, so it would be 8 pi plus, and then this would also be 8 pi, and then this is going to be equal to 16 pi. So it's going to be C. So let's go to number 23. If a right circular cone has a height of 14 inches and a radius of 5 inches, then which of the following is closest to the volume in cubic inches of the cone? So volume of a cone is going to be equal to 1/3 pi r squared h. So again, where r is the radius and h is the height, which they've given us right here. So all we have to do is plug in, it says the height is 14, so for h we're going to put 14, and they said that the radius is 5, so for r we put 5. So volume of a cone is equal to 1/3 pi times 5 squared, and then times, and then times 14. So then we're going to say that this is going to be equal to, and then we just multiply this all out and keep the pi, or actually don't, because it says estimate, because which is closest. So if we plug that into a calculator, so that's going to be 366 point something something something, so that's going to be closest to h. Okay, so then let's go to the next one right here. So it says for number 24, a parallelogram has a side length of 12 centimeters. If the perimeter is 90 centimeters, then what are the lengths? In centimeters of the other sides? Okay, so parallelogram, like this, guy right here. So it says a parallelogram has a side length of 12 centimeters. So let's say like this side is 12, this side is 12. And remember, parallelogram, the opposite sides are going to be equal. So this is 12, and we could call this x and this x. And it says the perimeter, meaning when we add up all the sides, is 90. So if we add all these up, so 12 plus x plus x plus 12, it should equal 90. So that's going to be 2x plus 12 plus 12 is 24. And then that's going to be equal to 90. So then I'm going to subtract 24 from each side. So then I'm going to get 2x is equal to, and then that's going to be 66. And then I'm going to divide each side by 2, and I'm going to get x is equal to 33. So that means that these have to be 33, so it would be b.